Okay, so our first speaker is Britt Fossum, and she's an agronomy student or a graduate student in the agronomy department, and she's doing some really interesting research with cover crops and biochar. So go ahead, Britt.
Hello, everyone. So today I am presenting on biochar in combination with cover crops as a new sustainable management strategy. So I might actually just start by outlining a little bit of background on sustainable management and some of the kind of encouraging developments. So Nebraska is an agricultural state, more than 20 million acres of cropland in total. And out of those 20 million acres, currently more than 50% are using some form of sustainable management, whether that's no-till, reduced tillage, or any kind of variation on that. And so something that I really like to think about is what kinds of new strategies are coming out, because clearly there is an interest in kind of moving towards more sustainable management and especially looking at soil health. So biochar is one of these. I might do a very quick poll to see if I can have a reference for that 50% for how many people are familiar with biochar already. Okay. Has anyone used it, actually? Okay. So we'll say maybe less than 1%. So also in context for sustainable agriculture, there are really a number of different goals. So there are equity goals. There are goals around the economic sustainability of the overall agricultural sector. And there are also specifically environmental goals. And today has been really centered around soil health, but there are actually a number of other things that can be addressed, such as better management of water resources, increasing biodiversity, and improving carbon sequestration. And so looking in at this, soil health is just one component of these sustainable systems. And a lot of new technologies and methods can actually target multiple goals at once. And that's kind of the goal of biochar. So this is really where biochar shines. It is one of the most efficient carbon sequestration strategies that we potentially have. And agriculture does contribute quite a lot to emissions. In the United States alone, it makes up nearly 10% of overall carbon dioxide and other equivalent gases annually. And a part of this is because of the organic matter in soils. So over the course of a given year, essentially during the growing season, you have plants in your soil that take up carbon dioxide from the atmosphere and turn it into their biomass. That isn't a permanent solution, because then as that plant decomposes, it begins to release carbon dioxide back into the atmosphere as carbon dioxide. Overall, soils can either store carbon or release carbon. And agriculture and agricultural intensification serves to kind of speed up that process. It makes it more likely that your soils are going to emit carbon dioxide instead of storing it. So any kind of solution that targets this and tries to kind of reverse that process could be said to be a carbon sequestration or storage technology. So that is kind of what biochar is designed to do. So this is just a really complicated diagram showing the biochar production process. So you start with some kind of plant material, and current projects, especially in Nebraska, are looking at feedstocks that could actually be a sustainable source of material for this process. In this case, it's an eastern red cedar or wood, but many other feedstocks can be used. This is converted through a process called pyrolysis, which is basically what happens when you heat up any kind of plant material without oxygen. And this actually kind of makes it develop more of the solid material instead of producing a lot of heat and energy. You're really producing more of this biochar material. And you can tailor this process in many ways. Then this material can be used for a number of different applications. And the biochar industry is still fairly small, but one of the largest uses of biochar is agriculture and related fields. And so in this case, it has a potential sequestration of 0.5 to 2 gigatons carbon dioxide per year if it's scaled up, if this becomes a really attractive technology. So this kind of explains a little bit about how biochar could be used for carbon sequestration. The This figure on the right is actually from a larger scale biochar production facility. And there are the three components that I think are important for the biochar industry and biochar adoption as a whole. One is sourcing that feedstock, that material that goes into it. One is developing better production so that it can be produced at a scale where it's usable for large acres of land. And then finally, finding somewhere to use it. Like I said, agriculture is currently one of the areas where it is used, but it's still a very small industry and a lot of different issues need to be worked out in order to make it something that is really feasible for more people. Once you've applied biochar to soil, and this is another kind of complicated diagram, but it is black carbon, so it is organic material, but it is very different than many other organic amendments. And one of the big differences is that it is highly resistant to decomposition. So when you put it in your soil, it really does stay there for a long period of time, possibly hundreds to thousands of years. More study is required to kind of fully track how it changes over time, but it is highly resistant to decomposition and kind of creates this new architecture in your soil. So this image up at the top right is actually an image of the surface of biochar. And so you have a material that really spans a wide range of sizes from kind of matching soil aggregate size, but with little pores that can really hold on to a lot of important components like soil nutrients, water, and this increased porosity and decreased bulk density, as well as additional water retention and nutrient retention, could be really important for soil health properties beyond just improving the carbon sequestration capacity or storage of soil. So there are a lot of challenges. One of the most significant is the high cost. This is partially because it is currently a very kind of small scale process. Most biochar is bought and used in a very small area. It's very local. And there's difficulty sourcing biochar feedstock in a consistent way. That ends up being one of the biggest costs of producing biochar is finding something consistently that you can then use to produce it. And market development and production costs need to be worked out a little bit more. And there is not a lot of data on long-term impacts done on our current agronomic systems. So this is actually just comparing the cover crops, no-till, and biochar that are kind of the three major, or at least the three sustainable management technologies that we're considering in our research. So there are a lot of input costs associated with biochar, but it is a one-time application. Once you've done this, you've basically increased the organic content of your soil for as long as you'll be using it. Carbon sequestration, cover crops and no-till kind of have low potential in that regard. But biochar has very high potential, and for soil health, we need to understand that a little bit better. So I am currently involved in a biochar project at UNL, working with Michael Kaiser as well as a number of other researchers. And we began this project in spring of 2021, applying biochar at a fairly high rate, about 28 tons per acre. For context, I think a lot of recommendations are closer to 10 tons per acre. And we're looking at 2 different field experiments with different climate and water management. And we additionally sourced all of this material from within Nebraska, using Eastern red cedar as a potential feedstock source for a Nebraska-based biochar industry, if that ever comes to pass. Our primary research goals. So we are not really looking at crop yield increases. What we really care about is trying to assess what benefits biochar has to soil, if it's improving soil health, and if it's actually sequestering carbon the way we think it is. So we're primarily looking at an increase in organic carbon, improved nitrate and water retention, and additionally, kind of measuring that biochar over time, seeing how much of it decomposes, how much we lose, whether it's due to erosion or any number of things, and additionally, seeing how it works in combination with cover crops. A very brief overview of kind of some of our results. So looking at carbon and more specifically organic matter, there's really not an impact that we've seen in cover crops and no-till. In biochar, we've seen maybe 1.5 to 2 times of an increase. And this is not even looking at a calculation of how much carbon we've sequestered. That's kind of a different calculation. For nitrate, we're really seeing more of an impact from our irrigation than from anything else. And then these are just some images after we applied the biochar. So at this point, it's almost been 1 full year. And then finally, just to go over a few conclusions. So biochar really is a promising new strategy. It's one that has a lot of room for growth, is what I will say. It's still very much in its infancy, being developed, and there are a lot of challenges associated with adopting biochar. But I think research in combination with a lot of new developments, including in Lincoln, they actually very recently were awarded a grant for about $400,000 to develop a wood waste recycling program for producing biochar at a citywide scale. So there is a lot of opportunity for development and growth. And then finally, just for questions, and if you're curious about biochar, I am here to answer any questions. Additionally, like I said, the Lincoln Biochar Initiative is currently developing their citywide biochar program, and there are additional resources available through the US Biochar Initiative, as well as international organizations. So thank you. Okay.
Yeah, I was involved with Brit's project, and just one thing that we noticed when we were applying the biochar, don't do it on a windy day. That's just all that I would have to say. But it was awesome, and it's a noticeable difference that you see in the plots later. It looks dark. So I think we have some questions here.
Speak right there. 2 questions.
Yeah.
One, I think you answered it. It's always a powder. And do trees make a difference? I mean, I think about all the trees being taken out across the Nebraska landscape for farming, and a lot of rough crap trees. Do trees make a difference?
Yeah. So to the first question, is it always a powder? No. That is kind of related to the production process. You can kind of, there is always going to be some really small particles associated with it, but it has a really broad range. So again, a lot of it's about how you make it and what you make it like from. If you've ground up your material, if you're using sawdust instead of wood, for example, that might make a big difference. But and then for what kind of plant material you're using, I mean, wood is just nice because, like you said, there's a lot of waste wood, and it has the potential to be something that could be a consistent source of fuel. But ultimately, you can use like residual corn material. Switchgrass is one I've heard about a lot, but that's one of the tricky parts, is kind of working out the kinks in the production process. So hopefully that answered some questions.
I have a question and a comment. I noticed in your presentation that you incorporate biochar. Does it have to be incorporated? And also, you haven't done any test on yields. What I read is that if it's not inoculated, you're going to have a yield guide to begin with.
So maybe for the first question, which was about incorporation, I would say yes, you really do need to do a little bit of tillage to get it into the soil. It's a really lightweight material, and you want it to mix with the soil so that it can actually interact with other things in there and kind of better support the soil or architecture. If it's just on top, it's not doing much besides maybe getting lost. And then the other question, was that about crop yield or about biochar yield? Sorry?
Inoculation.
Oh, inoculation. Yeah. So I'm not currently working on that, but that is a really interesting way to use biochar. It is 70% carbon, and the remaining percent is not much else that's of use. It really is this like almost architectural component. But inoculation with pretty much anything you want, or even adding and mixing it with other things, like maybe mixing it with compost or manure or any other organic additive you want, could be a really good way to maybe start off using it and try it out. And it kind of allows you to add both that carbon matrix as well as some actual nutrients that your soil might want. We said it was, so we're actually comparing, we're calling it a one-time tillage, and because it's a one-time application, it is kind of something that you just have to deal with. You're putting it in your soil, you're going to till that one time. And then after that, hopefully you've increased the carbon content of the soil for the next 100 years. So you don't need to do it again. But you're right. I don't think there are a lot of great strategies for incorporating it without using any tillage at all. But you can do it, like we only did it up to 6 inches with kind of as non-invasive a method as we could.
Thank you. So your pyrolysis equipment, is it mobile so that you can take it where your feedstock is, or do you have to bring the feedstock to it?
It can be mobile. So these can be as complicated as a large industrial process designed with, the most efficient method and most efficient fuel use, or it can be a kiln on a trailer. So honestly, the production scale can vary really widely and kind of depends on what you want to use it for. So you can do kind of a smaller mobile operation that maybe moves to where you have the feedstock that you want to get rid of.